Okay, so let's work through this first practice paper, which mirrors the non-calculator paper with all the topics that we've covered. I'll work through the first 7 questions. I'll pause the video clip and then work through the second set of 7 then. So it's not such a big file to upload. Right, so number 1, make m the subject of the formula y equals 6m plus 7. So when you're making something the subject of the formula, basically you're applying your rules of algebra, the way you'd solve an equation, but you're going to do that to get the whatever letter is the subject, in this case m, to remain on its own. So the first thing I've got to do here is take 7 off. To take 7 off there, I have to take 7 off this side as well, which means this side then becomes y take 7 and this side becomes 6m. Now I need to get the m on its own. I've got to deal with the 6. The 6 is attached to the m by a multiply, so I need to divide both sides by 6, just as you would if you were solving an equation. That then means this side becomes y minus 7 over 6. When we're in algebra, we don't use the divide symbol, that's arithmetic. And on this side, we have the m on its own because the 6's will cancel. So to make m the subject of the formula, that's equal to m, which means m is equal to that. So we write m equals y minus 7 all over 6. Factorize 6x squared minus 12x. So we're looking here for common factors. It's not a double bracket because we haven't got a number part on its own. I can see there's an x term in each, and I can see I can also take 6 out. So if I take 6x out of the brackets, it's just going to leave me 1x on its own there, and minus 2 for the other part. And the beauty with these is you just check by multiplying back out. So 6x times x is 6x squared. 6 times 2 is 12x. Positive times a negative. Signs are different. Answer's negative. This is an inequality. We're asked to solve it, and the rules for solving inequalities are identical to the rules for solving equations if and until you end up multiplying or dividing by a negative number. If you have to do that, you end up flipping the inequality so it points in the opposite direction. With this one, we're not going to need to do that. We're going to add 3 to both sides to get rid of that minus 3. Leaves me 7x on that side and 32 on that side. Then we're going to divide by 7, giving me x is less than 32 over 7. What is the greatest integer value of x that satisfies the above inequality? So what's the largest whole number that could be less than 32 over 7? Well, if you don't know what 32 over 7 is, you can break into bus stop land, because what we're doing is 32 divided by 7. 7 into 3 doesn't go. 7 into 30, 4 7s are 28, remainder 4, and then it doesn't matter what comes after that because it's going to be a decimal part, so the largest whole number is going to be 4. Question 2. 2 straight lines, AB and AC, are shown below. The point P is equidistant from the line AB and the line AC. So it's an equal distance from that line and that line. Now if you remember when we were out on the tennis courts doing this, if you imagine that those are the 2 fences in the tennis courts and I was asking you to stand so you're an equal distance from the 2, you were going to line up somewhere in between. So we need to cut that angle in half. So we need to do that. 6 centimeters from the point B, so the point B is there, and to be 6 centimeters from it we're going to draw part of a circle, and then more than 10 centimeters from the point A, so we'll come to that towards the end. So first up, let's do that equidistant. So to cut that angle in half, the angle A, which is where the two lines intersect, you get your compass. You open it out. You don't open it out to anything fixed, it just has to be open and a sensible sort of size. You put the compass point on A and you mark where the compass crosses the two lines. You then move your compass point to the first of those crossings and draw into the middle, and then you put the compass point there and draw into the middle, and P is going to lie somewhere on that line. You do it in pencil in case you get it wrong. So it's going to be on that point somewhere. It's going to be 6 centimeters from B. So using your compass and ruler, open now to 6 centimeters. Put the compass point on B and draw your circle like that. Okay, so it's going to be 6.6 centimeters from B. Anywhere on that curve, on that part of the circle, is exactly 6 centimeters from B because it's the radius of the circle. So it's going to be on that curve somewhere. It's also got to be on the blue line, so I need to extend that a little bit further just in case. Oh, come on, Jones. Which means it's got to be there or there, and it's got to be more than 10 centimeters from A. So again, now I need to measure 10 centimeters using my compass. Okay, compass point on A and draw another part of the circle. So this point has to be on the blue line, it has to be on that circle, and it's got to be more than 10 centimeters from point A. So it's got to be that side of the curve from A. So it can't be that one because that's closer than 10 centimeters. So it has to be there. So you've got one angle bisector, and then you've got two parts of circles to measure. Question 3, ratio. Share £720 in the ratio of 2 to 7. So that means that we need to divide that 720 into 9 equal parts, 7 plus 2. And that bus stop isn't going to really help you. You're going to need to go through your times table, and 9/8 are 72. So each part is worth 8. So the two parts are going to be worth 18, and then 7/8 are 56. So sharing £720 in the ratio of 2 to 7, one person gets £16, the other 56. Calculate the value of the reciprocal of 0.2. So reciprocal means turn it upside down. Or 1 over is another way we say. 0.2, the easiest way of doing this is to turn that into a fraction. Now 0.2, that's units, that's tenths. 0.2 is the same as 2 tenths. So the reciprocal of 0.2 means I've now got to turn that upside down to get 10 over 2, and 10 divided by 2 is 5. So the reciprocal of 0.2, first of all turn it into a fraction, 2 over 10, 2 tenths, or 1/5 if you know that equivalent straight away, doesn't matter. Then when you turn that upside down, it becomes 10 over 2, which is 10 divided by 2, which is 5. So that's question 3. Question 4, bit of probability. A fair 6-sided dice and a fair coin are thrown together once. Circle the correct answer for each of the following statements. Number of possible outcomes. Right, so what we need to do with a question like this is list all the possible outcomes we could achieve by rolling a six-sided dice and flipping a coin. And you want to try and do this in a systematic way, so you're organized. So the coin could be a head, and you could flip a head with 1 on the dice. It could be a head and 2 on the dice, or a head and 3, or a head and 4, or a head and 5, or a head and 6. You've exhausted there all the possible outcomes of throwing a head and rolling the dice. The other possible outcomes would be if the coin landed on a tail, and you could have a tail 1, a tail 2, a tail 3, a tail 4, a tail 5, or a tail 6. There's nothing else that could happen. Okay, don't start going down the lines of, oh well, the coin could land on its edge, or the dice could land on its edge. No, it doesn't. They're going to land heads or tails, and 1 to 6. So the number of possible outcomes are 12. There's 12 different things that could be presented when you roll a dice and flip a coin. The probability of getting a 4 on the dice and a tail on the coin is that one. There's the only one possible way you can get a tail and a 4 out of 12 possible outcomes. So that's 1 over 12. The probability of getting a multiple of 3 on the dice and a head on the coin. So here's the heads, and the multiple of 3. Well, there's 2 possible ways of achieving that, which is a head 3 or a head 6. So that's going to be 2 out of 12. And when you look at your list, 2 out of 12 isn't there, but you should be able to see that because you can divide both of those by 2, 2 divided by 2 is 1, 12 divided by 2 is 6. That's an equivalent fraction of that. So what they're looking for there is 1 out of 6. Question 5, transformations. Okay, so we're rotating. When we rotate, we need to know how much rotation we're going to have, 90 degrees, a quarter of a turn, which direction we're going to turn, anti-clockwise, so that's going to be in that direction, and where we are pinning our tracing paper. Okay, so the tracing paper is going to be pinned at -2, 3. The first number in a coordinate is always the x, and the second digit is always the y. So we're going -2 up 3. We are rotating about there. If you haven't got any tracing paper at home, go in your kitchen, and I'm sure your parents will have some greaseproof paper, which you can cut a bit off, and that'll do the tracing bit for you. So I'm going to pin it about there, and to know when to stop, put an arrow pointing upwards, and think about where that arrow is going to point when it's gone through quarter of a turn anti-clockwise, and it's going to be pointing for me in that direction. Okay, so we need to trace the shape, get that back to the start. So there's A, and I'm going to turn that now about that point which I've marked until the arrow is pointing towards the question number, and that then is going to be make sure you use a pencil, make sure you use a ruler. That's that one. Enlarge triangle B by a scale factor of half using 0, 0 as the center of enlargement. Okay, it's not a negative scale factor, so it's going to end up still moving in the same direction. So what you want to do here is work out the horizontal and vertical distance of each point and half it. So we're moving across 8 down 2. If we're halving across 8 down 2, we're going across 4 down 1. So that one is going to end up there. And then for this corner here, we're going across 8 down 8. So that would be across 4 down 4. And then this one here is across 4 down 8. It'll be across 2 down 4. Okay. If it had been a negative scale factor, then we would have reversed the directions. So rather than going across or to the we've got to change our language then, to the left 4 and down 1, we'd be going to the right 2 and up half, and so on. There's one of those in the second paper to practice, but that one's just a normal positive scale factor, but it was a shrinkage because it was a scale factor of a half. Question 6. The table below shows some of the values of y equals 2x squared minus 5x minus 1 for values of x from negative 2 to 4. Complete the table by finding the value for y equals x minus 1 and y equals x2. X equals minus 1 and x equals 2. Now when I went through this with you in class, what I suggested you did is before you work out what those points are, you plot the points that you're given, because that will give you a sense of whether or not when you calculate these you work them out correctly. Because y equals 2x squared minus 5x minus 1 should produce a smooth curve like that. So minus 217, oh this is a horrible grid. So first of all we need to work out what each little square is worth. Each little square in this direction is going to be 0.1, and in this direction 2 squares are going to be 1, so each little square is a half. So minus 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so that's minus 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so that's minus 2, and 17, 19, 18, 17. The graph paper you will have on your exam paper will be much easier to use than this. So it's there. So that's minus 217. We're leaving that one. 0 minus 1 will be there. 1 minus 4, so if that's 1, minus 1, minus 2, minus 3, minus 4 is there. We're leaving 2, then we've got 3 and 1, 2 and 4, 11. So if that's 10, 11 will be there. So if we look at what we're expecting, that minus 1 is going to be, I would say, around somewhere between 5 and 10. So if I work that out incorrectly, that should tell me that I'm wrong. Okay, so when x is minus 1, in our formula, wherever we see an x, we replace it with a bracket minus 1. Then work out the bracket. So minus times a minus is a plus, 1 times 1 is 1. So that's going to be the same as 2 times plus 1. This is going to be 5 times 1 is 5, minus times a minus is a plus, take away 1. So we've got 2, add 5 is 7, take away 1 is 6. So that fits my curve, I'm happy with that. So here's minus 1, there's 5, there's 6. And then when x is 2, y will be 2 bracket 2 squared minus 5 bracket 2 minus 1. And I'm expecting this to be, well, less than 5 but positive, 1 or 2. 2 squared is 4, so that's going to be 2 times 4. That's 10. Negative times positive is negative. Take away 1. 2 fours are 8. 8 take away 10 is minus 2. It's actually minus 3. So 8 take away 10 is minus 2. Take away another 1, minus 3. So 2 minus 1 minus 2 minus 3. When you're drawing your graph, use a pencil. Make sure your points are clear. Use crosses. And turn your paper around so your wrist is on the inside of the curve. Okay, and then just draw a smooth curve. You won't get the marks if you use a ruler. Okay, so there's the graph. So I've got 4 marks so far. I've got a mark for 6, a mark for -3, a P1 plotting, putting the crosses in the right place, and then a C1 for the smooth curve. Draw the line y equals 5 on the graph paper. Now, I made a big song and dance about this when we were doing reflections. Y equals 5 means it has to go through the y coordinate 5. And if it goes through there, and every point that has the y coordinate 5, then it means that you have to draw a horizontal line. So y equals is a horizontal line. X equals would be a vertical line. Write down the values of x where the line y equals 5 cuts the curve. So it crosses it there at minus 0.9, and it crosses it here at 3.1234. So minus 0.9 and 3.4. My red pen has just run out of ink. So that one. There's a bit of life in this one. So that is that question. And then question 7, standard form. So finding standard form, the value of each of these. The first thing to do here to make this probably the easiest is to turn 5,000 into standard form, which would be 5 times 10 to the 3. Remember, decimal point, 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, and so on. 5,000 would be 5 times 10 to the 3. Then, when you are simplifying this, you work with the number part first of all. So 7.5 divided by 5. 5 goes into 7 once, remainder 2. 5 goes into 25 5 times. And then with this part, when you're dividing, so this is the rules of indices now, when you're dividing numbers with the same bases, both the base 10, you subtract the indices. So 10 to the 6 divided by 10 to the 3 is the same as 10 to the 6 take away 3, which is 10 to the 3. So my final answer is 1.5 times 10 to the 3. So if you're multiplying or dividing standard form numbers, that's what you do. You multiply the number part and you deal with the index part. If it was a multiplication there, you'd add the powers. When you're adding or subtracting, it's usually easier to turn it into a number form and then turn it back. So I've got to go up to 10 to the power of 4 here. So there's my decimal point, 10 to the 0, 1, 2, 3, 4, 5, and so on. So I've got 2.3 times 10 to the 3. So the 2, most significant digit part, goes in that column. So I've got 2, 3, and then I have to fill in the gaps to the decimal point with zeros. And then 6.4 times 10 to the 4. So the 6 will be in the 10 to the 4 column. And then going to add those together. 0, 0, 3, 6, 6, and then turn that back into standard form. So it's going to be 6 times 10 to the 4, but it'll be 6.63 times 10 to the power of 4. Okay, so those are the first 7 questions. I'll pause that now and then we will complete the rest.